Alrighty, gents, how you doing? I've had a word with my client, and she likes this design. We've had a bit of talk about it, and she wants the times mark or the multiplication mark to be bigger. We need to have some sort of reset for the next question. So when you press the button, it goes on to the next question. We need an off and on switch as well. So she likes this shape, so that's what I'm going with. I'm just trying to work out now what my times tabling machine actually needs, and that's when we get onto these things called a system diagram. And I think it's worth looking at this before we go on to the final design stage, just so what we're designing, what we're putting in that final design is representative of what we need in our final product. So I've done two different systems on here. I've done system 1 and system 2. One is much more complex than the other, and so I thought I'd go through it with you. So what do you get on a system? Well, on a system you get input, you get a process, and you get an output. It's a bit like your heating system, where you've got your thermostat on the wall, which is the input. You've got your boiler, which is the sort of process digesting the information from the thermostat, and then you've also got the output, which is going to be the heat going to the system. And with your heating system, it's a circular system because it doesn't finish, it just keeps on going round and round in circles. So you've got your input here, which is a thermostat. If it's too cold in your house, the thermostat sends a signal to your boiler turns on, it produces heat which gets pumped around your house, and the output is the heat. Once the temperature gets to a certain level, and then the input senses it, the thermostat senses it and turns the boiler off. So you can see how that circular system works, and it's quite an easy one to understand. So in this first system, what I'm going to do is not think about answers, just think about how can we produce two random numbers, and then my daughter can just do that in her head and then check herself if it's correct or not. So what do I need for that? Well, first of all, I need an on and off switch, and you can see here, first thing we've got here is a power on and off switch. And what else do we need? Well, we need some sort of button that we press, and then it produces that random number. So we press it once, produces those two random numbers, and then we wait and we work that sum out, then we press it again, it produces two random numbers. So that just gives you a signal. So that's going to be linked to one of the inputs on the Genie. The Genie is here. I put a 14 in there just because I quite like the 14. I think the 8 is a bit limited, so I put a 14 in there. Might get away with an 8 here. And what does it do? So it gets a signal. What we should say first, is you've got the input. So we're turning the Genie on. When the Genie is on, we then have an output. We have a power LED just to show the product is on, and I'm sure you're very familiar with that. Then what is the Genie doing? It's waiting for the signal from the push to make. We press the button, it gets a signal from the push to make. It then creates two different random variables. Let's call them A and B. And if a random variable A is 5, what it does is it pulses, let's say Q1 5 times. Those 5 pulses get interpreted by the 4026, which is a driver for the 7-segment display. So if it pulses 5 times, the configuration on that 7-segment display will show a 5. And so we can see how very easily, and if the other one is a 7, for example, the other random variable, which will be random variable B, then that 426 pulses 7 times, and that gets shown on that 7-segment display. I suppose then what we would do is, once we've worked that sum out, we'll come back over, we'll press the push to make again. Press that, and it would create two new random variables for A and B. So it wants to reset everything, doesn't it? So how does that work as a sort of flow chart, as a system? Well, we've got the single pole, single throw at the top. That's the power. Genie comes on, LED. The power is on. So it's waiting then for the push to make signal, this signal here. So once it receives that signal, and then the Genie creates two random variables between 0 and 9. I've put that in there just because later on I was wondering about the resetting function of it. Okay, so it's created two random variables between 1 and 9. If the first one, random variable A, is 7 or whatever, it's going to make sure that it pulses 7 times. So it pulses equal to the number of the variable. And then that 4026 will receive those 7 different pulses, and it will then what's called clock those different pulses, and the output will be configured so it shows a number 7 on the 7-segment display. Does exactly the same on the other side. So we get those 2 different random variables. I'm just going to close the door a second. All right, so let's go on to the times tabler, which is a bit more complex to say the least. And this is, okay, we've created 2 random variables. We've created the 7 and the 3 or whatever. We're saying to my daughter, what is 7 times 3? But can we then create an answer? Can we tell her if our answer is wrong or right? And in this, the suggestion was that we could do that. So we could have 2 buttons, one which increases the tens by 1 and one that increases the units by 1. And I suppose if you pressed it and you wanted to put in 27, for example, and you got to 27 and you double pressed it and went to 28, I presume you would keep on pressing this and it would go round from 7, 8, 9, and then it would go to 0 again. So it sort of reset itself. So how can we do this? Well, I've started in exactly the same way as last time, in the respect that we've got the single pulse, single throw is the power. We've got 1 PTM is a sort of start functional signal. I've then got a PTM, push to make, which is this button, and I've got another PTM, which is that button. And what I've sort of missed off of here is it's okay if it had 7 times 3 and we put in 21, but how can we then say, okay, I want to press something to understand if I've got that correct? I mean, I suppose we could have a timer, and after 10 seconds it does it automatically. But I think it may be better if we had a button. So I suppose that button there is the button you press, and then you'd say, is the sum correct or not? And if it is correct, we would have a nice happy tune play. And if it was incorrect, there'd be a sad tune play, I suppose. And you could also have a cumulative score here. So if you get 1 right, you get a score of 1. If you get 2, you get a score of 2, for example. So cumulatively, how many are you getting right in a row? So let's pop back onto this. We've sort of talked through these, haven't we? Push to make, units going up, push to make tens going up. We've got push to make finished answer. So if we think that's correct, we then press that one to find out if the answer is correct. And we have a Genie 14 to sort of run all this. And because we've got 4 of those 7-segment displays, 1, 2, 3, 4, we're going to need 4 7-segment displays, of course, but we're also going to need 4 7-segment 426s. And so we've got our 4 426s. I've labelled them 1, 2, 3, and 4, and they control each one of the 7-segment displays. Makes sense so far, yeah? We've also got down here, we've got a speaker. And so the Genie can, if the answer is correct, can play a happy tune or a sad tune. I hope so far it's seeming pretty obvious and you're thinking, yeah, I sort of get that. So let's get on to the more difficult section. And I think for that, what I'm going to do is try and take you a little bit closer. Right. Hopefully you can see that a bit better. So what I've produced is a system here, system diagram, where it's a flow chart, it's a programming diagram really. Got two different programs on this. We've got this section here, which is the first program. And then we've got that section there, which is the second program. Now, indeed, if we were using a Genie 08, we can't run 2 programs together in parallel. So we wouldn't be able to use that anyway, and it hasn't got enough outputs. So let's just go through this and just see why I've used the 14. So start, single pole, single throw is the power. We've got that. Genie is then turned on. Genie puts one of its keys, let's say key 0, goes high, and that then powers the LED. Should just put that in there, Q0. Then the LED goes high to show it's on. The Genie's waiting to start, and it's waiting for that signal, isn't it, from this button. I think we need 2 buttons up here, don't we? So I think we do need that one in actual fact. So it's waiting for that signal, press the button, that signal, and it starts. It produces 2 random variables, A and B. A and B are going to be between 0 and 9. And it wants to show those because it wants to show the sum. So we go over here. If the first one is 8, for example, the first random variable, so A equals 8, then output, which would be, let's call that Q1. Q1 will pulse 8 times. That will be interpreted by the 426, and the configuration on that 7-second display will be 8. We've got the second one here, and that's going to come out of Q2. So at Q2 does exactly the same for the second variable. And I'm going to put down there A, and I'm going to put down there B, so we know what variables these refer to. Okay, the number. This is getting a bit more complicated. So we have 2 new variables which we're going to plug into this. You can press one of 2 buttons. You can either press this button, just bring it down a little bit, this button here, or this button here. If you press this button here, it will increase a variable, which we're going to call C, by 1. So every time, actually I'm going to call that variable D. I'm going to call that one C because it's a 10. So it sort of makes sense to be in that order. So push to make units. Every time you press that button, variable C increases by 1. And so, as I said, you would go up, up, up to 7, 8, and if you went too far, you'd all go all the way around and back again. So we can see here that that is C. Every time you press that button, random variable C increases by 1. And that in turn will pulse and show on the 4026 the number. So every time you press it, the 4026 moves up by 1 number. And then if you go all the way around, it will go from 9 to 0 to 1. And that's how a 4026 works. Every time it receives a pulse, it moves up by 1 increment. And exactly the same would be happening over here, which is D. So we can sort of understand how it's all working now. However, how can we see if it is correct or not? And I'm going to put a little line around here. We can run a second program, and we could call this answer or something opposed to, we can rename that answer. And what we can say is we can say, does A times B, and A and B are down here, of course, the variables A and B equal C and D. So C times D. And if A and B equals C times D, then increase variable E by 1. Now what is variable E? That was that's going to be the score. So I'm just write that on there. So score is variable E. And if A times B does equal C times D, then we're going to increase E by 1 and play a happy tune. But if it doesn't, then we play a sad tune. And so that shows we can have a timer on this, for example, and we've got to get the biggest score as we can in, I don't know, a minute or something. And after a minute, what it could do is on one of the 7-second displays, it could show your final score. So you can sort of see how this really complex system can be represented, and I hope you understand that now. And we can go on to do our final design. But what we know is what different components we need. Like we need a circuit board with 4 4026s in there. We're also going to need a Genie 14. and we're going to need a number of inputs and outputs. So I can represent all of that on my final design. I hope that makes sense, and I'm hoping that you're going to have a look at this before our lesson on Thursday. All right, cheers.